Sri Lanka Institute of Information Technology, Programming Languages and Design Concepts, 3rd year, 1st semester, Assignment Part 1. These are the team members involved with this work. Common principles for any programming language. This video is based on common principles for any programming language. These languages are the base for any programming language. With this video, further we discuss about how programming languages violate these principles. We mainly focus our attention about FORTRAN. But not only FORTRAN, there are some other language violations as well. We have included some examples in order to understand them. So, now we can move on to the principles. The first principle, the structured principle. The definition is the static structure of a program should correspond in a simple way to the dynamic structure of the program. In generally, we can say the execution of a program should be easy to trace given its source code. To get a more idea, now we consider about an example. As an example to this, we can consider about a for loop. In a for loop, there are three main parts: assigning, comparison, increment or decrement. So, after seeing the static behavior of the for loop, we can get a rough idea about its dynamic behavior. Though the situation is like this, there are some violations for FORTRAN as well as the other languages with this structured principle. Now we will see how FORTRAN violates this principle. Violations of the principle by the programming language. Go-to statements are required in FORTRAN to emulate while loops. And there are three similar looking versions of the go-to statement with different behavior: simple go-to, computed go-to and assigned go-to. Simple go-to. The definition is jump from one line to another. Computed go-to. Transfer control to one set of labeled branch target statement based on the value of an expression. And assign go-to. The assign go-to statement transfers the program control to an executable statement, whose statement label is designed in an assign statement. If these three types of go-to statements are doing three separate tasks, we cannot identify separately what type of go-to statement is it. So, from this point, FORTRAN violates the structured principle. Not only FORTRAN, ADA also violates this principle. ADA's exit statement is scantily distinguished go-to statement. ADA can exit loops at multiple locations. Like this, ADA and FORTRAN violate this principle, structured principle. Now move on to second principle, syntactic consistency principle. The definition is things which look similar should be similar and things which look different should be different. In generally, we can say the language should have visually different construct to avoid confusion. Now we will consider about an example. In generally, we use plus symbol for addition an asterisk symbol for multiplication. Think a situation like use plus symbol for both operations. What will happen? At that time, computer will confuse what the operation is, and also we can't get the expected output. But FORTRAN violates this principle. How? FORTRAN uses asterisk for multiplication and double asterisk for exponents. In a case, the programmer had used double asterisk for both multiplication and exponent. With this case, that will give some output without any exception. But is it the output we expected? No, it is not the output we expected. It is different what we are expecting. But this type of errors we can't handle with the FORTRAN. Integer variables can also hold characters in FORTRAN. The simple computed and assigned code statements in FORTRAN are different but look similar. Not only FORTRAN, C and C++ also violate this principle. C uses asterisk for both the reversing pointers and multiplication. Identifiers are case sensitive in C and C++, meaning different variables can have very similar names. Like that, C, C++, FORTRAN violate this principle, syntactic consistency principle. Now move on to third principle, 0-1 infinity principle. The definition is the only reasonable number in a programming language design are 0, 1 and infinity. In generally, we can say a programming language construct should be limited to being singular, 0 or able to scale to infinity. Now we will consider about an example to get a further idea. In the file directories, the topmost directory has 0 parent directories. Each subdirectory has exactly one parent directory. Each directory may contain an arbitrary number of files or subdirectories. But FORTRAN violates this principle. FORTRAN limits identifier names to 6 characters. So, it will violate the condition infinity since they use 6 characters. It is an integer and fixed number. FORTRAN limits arrays to 3 dimensions. And also there is some special example which operating system violates this principle. Some operating system impose a hard disk limit of 65,536 files in a directory. Like that, FORTRAN and as well as some operating systems violate this 0-1 infinity principle. Now we will move on to the fourth principle, abstraction principle. Avoid recurring something to be stated more than once. Factor out the recurring pattern. In generally, we can say any commonly occurring pattern in the program code should be recognized and able to be implemented such that the repetition of the pattern is minimized. Now we will consider about a simple example. Think, in a single program, if you want the same function in 25 times, is it practical? In our point of view, it is not practical and it's time wasting. What we can do for it? Simply, you can create an object from this class and call the function whatever the place is necessary. But FORTRAN violates this abstraction principle. FORTRAN 77 does not support pointers and heap dynamic variables. So, binaries must be implemented using parallel arrays. FORTRAN 90 does not have records, so arrays of records must be emulated using parallel arrays. Now we will move on to the fifth principle, defense in depth principle. The definition is, if an error gets through one line of defense, then it should be caught by the next line of defense. In generally, we can say there should be exit multiple checks for errors in a program such that error detection is maximized. Look at this example. You will surely get some understanding in depth. If an error is not recognized in syntax checking, it must be recognized in type checking. It means that error should be detected and caught at least one place. But FORTRAN violates this principle. How it will happen? FORTRAN does not have exception handling or type checking. So, how will it find errors? There are no error checking method in FORTRAN. FORTRAN PLI and Perl have implicit variable declaration. Not only FORTRAN, C also violates this principle. C originally failed to type check parameters passed in function calls. Like that, FORTRAN and C violate the principle, defense in depth principle. Now we will move on to the sixth principle, information hiding principle. The definition is, the user has only the information required to use a module and the implementer has only the information required to implement it. Changes in implementation does not affect other code, only changes in the interface. In generally, we can say necessary information should not be visible or modifiable. Now we will consider about an example. Think a situation most of us logging into the Facebook through web browser in order to chat with friends, find friends and to have fun. Do we need to know what are the mechanisms inside the process? No, actually we don't want what will happen with the database, with the browser and what are the various implementations. But FORTRAN violates this principle, information hiding principle. All information for passing in FORTRAN apart from common block use is done through parameters passed by reference, often forcing the programmer to specify more information than necessary. So, this is the end of the video. We discussed about 6 principles and programming language violations as well. Thank you very much about your consideration.